Okay, I gotta repeat this. Explaining acids and bases using reactions. So acids produce hydronium in water environments. Bases produce hydroxide in water environments. Okay, so Arrhenius's definitions worked for most acids, but not all. Okay, so there's a different thing that we have to kind of consider is how this works when it reacts kind of with water to produce hydronium or hydroxide ions. Okay, so let's say that we decided that we have sodium hydrogen sulfate. Okay. So sodium hydrogen sulfate gets dropped into water, let's say, okay, and for some reason, the pH level is given to us as 4.5, we'll say, okay? So this is what we're talking about in terms of explaining how things react or can be considered acids or bases, okay? We're looking for something that's going to produce a hydronium ion to give us that pH level, okay? So the first thing that's ultimately going to happen, okay, initially, what type of a substance is this? It's got a positively charged ion there. It's ionic. So in this case here, the first step is that this is actually going to do a dissociation, okay? So dissociation breaks up the sodium and the hydrogen sulfate.
Then it dissociates more, or then it ionizes.
Yeah. Okay, so new definition for you guys, okay? So, of these two, which one of these are likely to possibly kind of seem like an acid or a base? Would it be the sodium, or would it be the HSO4 negative 1? It's actually probably the HSO4 negative 1. That's the one that's going to be useful to us. One of the things that we look for to identify whether or not it is useful with that, there's that hydrogen old definition that we can actually kind of apply in here. Is there a way to fit a hydrogen or take off a hydrogen from that original substance, okay? Now what happens to the sodium, okay? Sodium actually has like a name for itself as well. This is called a spectator ion, okay? So in a situation here, okay, like the name indicates, it spectates. It likes to watch. Kind of creepy. Okay, but otherwise all it does is that it does not participate in the actual reaction itself. It just sits back and lets everything happen in front of it, okay? So it's a spectator ion. So ions that do not participate directly in reactions, okay? So sodium in this particular case would be considered to be a spectator ion. Sodium is not going to have anything to do with us being able to show that that pH level is a 4.5, okay? Now your next step, and this is stuff that building steps for Chem 30 for next year, okay? There's a whole unit that's also acids and bases oriented. Now we're going to take a look at what is going to further progress with the hydrogen sulfate, okay? So the hydrogen sulfate polyatomic ion is going to be sitting in a water environment, okay? So in that water environment, is it possible that maybe, hint, hint, okay, maybe there's going to be a hydrogen transfer somewhere to produce that kind of acidic look to it? Is that possible? So on the right-hand side, the reason why it's possible for us to produce a hydronium ion is that H3O could get produced. Now, how that happens is that perhaps in the water environment, okay, this one hydrogen actually goes and jumps onto the water to produce that hydronium ion, okay? Now, if this one loses a H positive, what do you think the other substance is now in the water environment? SO4, what's the charge now? 2 negative. It's lost a positive 1, so it kind of becomes a little bit more negative this way, okay? So this is the substance that we're looking to get to produce or kind of manipulate in our own way to show that the pH is a 4.5. Now, does that make sense? if we produced an acid, we should have hydronium ions somewhere present in the final water environment. Everybody agree?
Yep.